Hi everyone, welcome back. We are now in Module 3. We are in Topic 1, Lesson 1 on page 345. Relationships Matter, Evaluating Numeric Expressions. I think you guys are really going to like this unit. Our key terms: perfect square, evaluate a numeric expression, perfect cube, and order of operations. These are some things that you're already familiar with and we've already talked about this year. So let's get started. Learning goals. Interpret a number raised to a positive integer power as a repeated product. Identify perfect square numbers and perfect cube numbers. Write and evaluate numeric expressions involving whole number exponents. Model numeric expressions with 2- and 3-dimensional figures. Evaluate numeric expressions using the order of operations. Okay. Write each power of 10 as a product of factors, then calculate the product. So this is something that we've already done this year. So 10 squared, 10 to the second power, 10 raised to the second power, 10 to the power of 2. We've already talked about all of those things this year. We know that that means 10 times 10. The 2 is the exponent. It's telling us how many times we multiply the base, this bigger number, by itself. Let me zoom in here a bit for you. Hopefully I remember to slide it around. So 10 raised to the second power is 10 times 10, which is 100. Okay, number 2 says 10 to the 5th. So the 5 tells us how many times we're writing the 10. So we're writing that 10 5 times, and we're multiplying it each time. So 10 times 10 times 10 times 10 times 10. So it's a 1 with 5 zeros. So we have 100,000. 10 cubed, 10 to the third power. So 10 times 10 times 10, which equals 1,000. And then finally 10 to the fourth. So you can even do this. So when you see that exponent of 4, you could draw yourself 4 lines. A lot of kids end up doing 4 times 10, but if you draw yourself 4 lines, that will help you to not make that mistake. Then you know you need to go back and fill in the tens. So 10 times 10 times 10 times 10 is 10,000. Okay, moving on. Getting started, powerful expression. Recall that an expression is, in mathematics, is a number of a combination of numbers, a number or a combination of numbers and operations. You have written expressions equivalent to the area of a rectangle, length times width, and also the volume of a rectangular prism, length times width times height. Consider the area of a square and the volume of a cube. So in area of a square, it says because all sides of a square have the same length and width, you can write the formula for the area of a square as the capital A for area, as A equals side times side, or A equals side squared. Okay, so write the area of each square as a repeated product, as a square number, and as an area in square units. So there's 3 things they want us to do. So these 3 things for each of them. Okay, so when we do that, so as a repeated product, so if area equals side times side, is going to be area equals 2 times 2. So area equals 2 squared, which then the area equals 4 inches squared. Okay, so then letter B, side length of half of a foot. So it's still the same thing. So we still have side times side. So area equals 1/2 times 1/2, which is the same as 1/2. Because we have the two of the same thing repeating, we can write it as 1/2 squared, which it equals 1/4 feet squared. Okay, side length of 1.2 centimeters. So side times side. So area equals 1.2 times 1.2. We can write that as 1.2 squared. Now I know 12 times 12 equals 144. And there's a number in the tenths place and the tenths place, so tenths times tenths is hundredths. So our decimal needs to show hundredths place, or one number after the decimal, one number after the decimal, two altogether, centimeters squared. So there's our final answer in these. Okay, write the volume of each cube as a repeated product and as the cube of a number and as the volume in cubic units. Okay, so basically we're doing the same thing, but this time we're doing volume, because volume is side times side times side. So if we've got a side length of 2 units, we're doing 2 times 2 times 2, which also looks like 2 to the 3rd power. 2 is our base. It's the number that's being repeated. It's being repeated 1, 2, 3 times, so our exponent is 3. 2 times 2 is 4 times 2 is 8. So our volume equals 8 inches cubed. Side length of 2 feet, so volume equals side times side times side. Or they write it as volume equals side cubed. So let me fill it out like that. So we have 2 times 2 times 2, or volume equals 2 cubed. So those are saying the same thing. You can't see it. My apologies. Okay, so this is saying the same thing as this. The 3 is the exponent. It's telling you how many times to multiply 2 by itself, which is 3 times, so 2 times 2 times 2. So the volume is 8 feet cubed, or you could even write it cubic feet. Either is correct. Okay, so then letter C, side times side times side, or volume equals side cubed. So we have volume equals 1/3 times 1/3 times 1/3, or volume equals 1/3 cubed. So if we multiply straight across, 1 times 1 times 1 is 1, 3 times 3 is 9, 9 times 3 is 27 centimeters cubed. Same thing here. And again, you could write it like this, cubic centimeters. Okay, moving on. Next page. So it says some of the areas that you wrote in the getting started are called perfect squares because you can express them as the product of 2 equal whole numbers. For example, 9 is a perfect square because 3 times 3 equals 9. Another way that you can write this is the mathematical sentence 3 squared equals 9. You can use an area model to determine perfect squares. Daniel drew on the diagram to show that the expression 4 plus 4, that quantity, squared, is equivalent to 8 squared. Okay, and there you can see his drawing of that and what he has done. Okay, So down here at the bottom then, it says, explain why the quantity of 4 plus 4 squared is equivalent to 8 squared and not equivalent to 4 squared plus 4 squared. Okay, so this tells us to do, so if we have 4 plus 4 and that quantity squared, that says add the 4 plus 4 together first, and then do 8 times 8, which gives us 64. The other way they have it written is 4 squared plus 4 squared. 4 squared is 16 plus 16. That would give us 32. Then it says we are to write some other expressions that are equivalent to 8 squared. So we can do anything as long as we get 8 inside the parentheses. So for example, we could do 10 minus 2 squared. We could do 5 plus 3 squared, 7 plus 1 squared, and so on. So it says, how can you use the grid to determine the square of any number 1 to 15? So if we have 8 all the way across here and 8 down here, it's taking up all of these blocks here, which there would be 64 of them. And if we think about this as the multiplication grid, then these perfect squares that are written in here, which is like the 8 times 8, like this would be 64. 9 times 9 would be here, that's 81. 10 times 10 is 100, and we have 121, and so on. So we could keep going right down there on that diagonal. And they're telling you what they are up here too. So 13 squared, sorry, I'm at 12 squared, 144. 13 squared, 169. 14 squared just flips around those two numbers, 196. 15 squared, 225. Okay, and these are the perfect squares that you should have memorized, 1 through 15. Oh, and that's going to bleed right through. Would you look at that? Isn't that lovely? Write 2 or more equivalent numeric expressions for each perfect square. Okay, so we could have 6 times 6. We could have 3 plus 3, and then that quantity squared, because that would give us 6 squared, which is the same as the 6 times 6. For the 12 squared, we could say 12 times 12, which is 144. We could say 10 plus 2, that quantity squared, because we have to add what's inside first. So we would have 12 squared, which goes back to the 12 times 12, which equals 144. Okay, I want you to highlight, underline, do something, this phrase right here. To evaluate a numeric expression means to rewrite the expression as a single numeric value. So that's all it means, is to just get this all down to a single numeric value. You can use parentheses to group numbers and operations. You can think about expressions inside parentheses as single values. Okay, so use the diagram to rewrite the expression with fewer terms. Explain your work. Okay, so let me rewrite this. So they have 7 minus 3, and that is squared, plus 10 minus 7, and that is squared. Okay, so the quantity of 7 minus 3 squared, 7 minus 3 is 4, and then that still has squared, plus here we have 3 squared. 4 squared is the same as 4 times 4, right? 4 times 4, which is 16, plus 3 squared is 3 times 3, which is 9. I want you to be able to go from this level to this level without necessarily writing these. And then when we add those together, we get 25. Okay. A perfect cube is any number you can express as the product of 3 equal whole numbers. For example, 216 is a perfect cube because 6 times 6 times 6 equals 216, or 6 cubed equals 216. The table shows the cubes of the first 10 whole numbers. So 1 cubed is 1, 2 cubed 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, 6 cubed 216, 7 cubed 343, 8 cubed 512, 9 cubed 729, 10 cubed is 1000. And then moving on here, it says write 2 or more equivalent numeric expressions for each perfect cube. So 5 cubed, we could write that as 5 times 5 times 5. We could also write that as 125. We could write that as 1 plus 4, that quantity cubed. Anything that adds to 5 inside here would work. So 2 cubed, so we could have 2 times 2 times 2. We can call it 8. We could say 1 plus 1 cubed. We could say 5 minus 3 cubed. We could even do, let's say 100 minus 98 cubed, because we still get 100 minus 98 is 2. All right, so it says, but remember that in general, you can represent repeated multiplication as a power. So we have the base number, the blue one. The base is the big, base, big. And the 4 is the exponent. Together, it's called a power. The base of a power is the factor multiplied by itself repeatedly. And the exponent of the power is the number of times you use the base as a factor. Number 5 says identify the base and exponent in each power, then write each power in words. So in this one, the base is 7. The exponent is 5. And then we could say 7 to the 5th power, or 7 to the power of 5. Okay. All right, so then this one, that's an 8, 4 to the 8th. So our base is 4. Zoom back out some now. Our exponent is 8. We could say 4 to the 8th power. EIGHTH. Or 4 to the power of 8. You could say 4 raised to the 8th power, 4 raised to the power of 8. All of those say the same thing. Okay, and that's where we are going to stop